Welcome back. This lesson is in continuation of the previous lesson where we learned about few aircraft systems. So now in this lesson we will learn some more aircraft systems. Okay, in the last lesson we left at firefighting systems. Let's move on. In this lesson let's start with the power plant. There are several types of power plants that are fitted in aeroplanes, and the most important, the most popular, and the most modern are the jet engines, which we will spend some time trying to understand more about this. Here, I have shown a picture of a jet engine, which you are all very familiar. So let me go through some more details. This working principle of a brief working principle of a jet engine is what we are going to see after some time. But at this stage, it's enough if we understand that these jet engines are efficient for long range flights and high altitude flights. That's why all long range flights by airlines and all, they have planes with jet engines, turbojet engines, or and of course they are very highly reliable. They are tested, and they have been tested over a period of time, and the technology has been refined over and over again. Now we have reached a very high level of reliability for usage of such jet engines. Also, I just want to add here that the fuel used is something called the aviation turbine fuel. By and large, it is same, though it is known in different places uh, in different names. It is the generally it's the composition is very close to being same. It's just very highly refined kerosene. So that's what is the aviation turbine fuel, which makes it fairly low cost when compared to other types of engines for very long range flights. In this picture, I've shown a piston engine aircraft, and I don't have to elaborate too much about piston engines. By and large, everybody is familiar. The piston engine principle is incorporated in all our two-wheelers and three-wheelers. Similar engines are all fitted. Of course, they are all much highly reliable and much tried and tested engines. Now, now not very many planes nowadays incorporate such these engines, but I must add at this point that most of the training aircraft uh, incorporate piston engines, and it is fairly cost effective for a training aircraft. And the fuel used is the normal petrol, slightly more refined petrol, and it is called 100 LL, 100 octane, or 100 LL it is called. Now, if you see in this picture, these the cylinders are arranged around a circle, radially arranged engines, and there are engines with cylinders arranged in a linear fashion or in a V-shaped fashion. Several arrangements are possible. So even now there are very many small range aircraft which use this piston engine, though soon they are not going to be used that very often in not very many planes. Here is another type of engine. These are called the turboprop engines. You can say this is almost a combination of the earlier two types of engines, and it's actually a jet engine to which some propeller is attached to it through a reduction gear mechanism, etc. So this is very popular for our regional airlines aircraft, with seated capacity of 50 to 70 seaters, and flying not very long ranges, of 1.5 hours or 2 hours, maximum 2 hours flights. These are all very efficient for such types of flights. So efficient for short range flights and medium altitude, and very cost effective for mid range and medium altitude and regional routes airlines. So these types of planes and engines continue to be popular for in every place, and you can see the picture which I have shown. So this is the turboprop engines. As I told you earlier, these jet engines are the most popular and very reliable and most widely used in planes. So I would like to spend some more time in trying to little bit elaborate construction of a jet engine. There is a intake, and there are the first part of the jet engine is called the compressor. Compressor is a series of fans, blades, fan blades so called, which compress the air in stages little by little to a very high degree of compression. So there are different types of compressors, which is well beyond the purview of this lesson. But it's enough to know that we are able to compress this air to a very high degree. And as I told you, the fuel used is uh, aviation turbine fuel, which is refined kerosene. Now that refined kerosene is again mixed with this compressed air in appropriate proportions, with very finely calibrated and appropriate proportions. Now, and the whole mixture is burnt in a part called combustion chamber, which I have shown in highlighted in this combustion chamber in this reddish color. So when this mixture burns, it burns at a very high temperature, and it releases very high pressure gas. This high pressure gas, it goes and hits another series of blades called the turbine, which in turn rotates the compressor. In fact, it is from here that the compressor derives all its power to uh, rotate and compress the air. In fact, in any jet engine, more than about 50 to 60% of the turbine power is used to drive the compressor. Remaining power, remaining power of the gas is sent out through the rear, which is called the exhaust, and which gives the forward momentum or forward push to the aircraft. This is in brief working of a jet engine. Of course, there are much more complexities attached to this, and every part of the jet engine is very finely balanced, and every rotating part is checked for accuracy, and it undergoes several tests. So at this point, it's enough to know that it's a very finely tuned, balanced machine that compresses the air, mixes with the fuel, and rotates the turbine, and comes out with a force through the exhaust, which gives the forward push to the aeroplane. Okay, here I've shown the cutout of a jet engine picture. As you can see, the blades of a compressor, which I've shown in the left side of the screen. This is how different stages of a compressor look like. And here I've tried to highlight the other parts in the cutout of a jet engine. I've shown both the parts. One is the compressor section and the turbine section. And of course, the combustion chamber in which the air fuel mixture is burnt is located somewhere in between these two. let's go on further. Additional information. Earlier lesson I have talked about auxiliary power unit. Traditionally, the auxiliary power unit is also considered part of the power plant unit, though I have not covered it here because it has been covered earlier. But we must understand the auxiliary power unit has got the same construction, same working principle as that of a jet engine, and though it's much smaller in size and power, it is not actually used to produce any thrust to push the aircraft forward. These are the basic differences. Okay, let me talk about something more interesting, the thrust reversers. The thrust reversers are constructed in the aircraft engines to provide rearward thrust after landing so that the aircraft can decelerate fairly fastly. You must appreciate that the aircraft lands at very high speeds and the brake system may not be good enough to commence braking at that high speeds because it may generate very high levels of temperature. Therefore, almost all jet engines have thrust reverser systems which produce the reverse direction thrust to decelerate the aircraft immediately after landing. There are two types of reverse thrusts that are employed in the aircraft. Both the photographs I have shown, the one on one side, there is a bucket-like structure which is operated by the pilot with a lever, which will come out and stop the river flow and in fact direct the flow of the jet exhaust in the opposite direction, providing thrust in the reverse direction, thereby giving retarding effect. Similar principle is employed except that the stream from the turbine area and the compressor area, between the compressor and the turbine area, is directed towards the front direction in which the plane is landing, which is providing the retarding effect. These types of thrust reversers are very popularly employed in all these airline jets, and the bucket types ones are deployed in planes which are all incorporated in smaller business jets type of aircraft. Next system which I am going to talk about is a very important system, that is the hydraulic systems. There are a lot of services in the planes like controls, and there are a lot of moving parts which require a lot of pressure and power to initiate the movement of the jacks of such services. For example, lowering of undercarriage system or raising of undercarriage system. These require very high pressure, power to do this because as such these components are very heavy and they require a lot of power. So this hydraulic system is incorporated in every jet engine to carry out these movements. What are the services that it operates? We will see subsequently. The hydraulic system, I have shown the system diagram, which is not very relevant, but I just wanted you to develop an understanding. There is a reservoir and there is a pump which is driven by the engine which builds this hydraulic oil to a very high pressure, almost up to 3000 pounds per square inch, and thereafter it is routed through different pipelines for various services to be operated. And of course, there is an accumulator which is able to trap this pressure and release it in case of an emergency. Also, as you can see, because of its importance, there is an additional measure by which a pilot can operate a hand pump from the cockpit to build any shortfall in pressure that may occur in the hydraulic system. Okay, here I've shown the picture of a hydraulic tank which is normally used in planes, and if ever you get a chance to peek in, you will be able to recognize a hydraulic tank very easily from its characteristic shape. I have shown another picture of a hydraulic pump, which usually is driven by the engine, and of course, just to make the lesson interesting, I have shown, as you can see, the hydraulic oil here is drawn from the reservoir and then sent into this pump, and thereafter very high pressure is built up, almost up to 3000 pounds per square inches built up and routed through different pipelines for various systems. The systems that are usually operated by the hydraulics system, as I mentioned earlier, one of the important systems that is being operated by hydraulic system is the undercarriage lowering and raising, and the next one is all the flight controls, all the primary flight controls of the plane, that is aileron, elevator, rudder, in almost all modern jet engines is being operated by hydraulic systems. Why? Because the flight controls require lots of pressure and power to operate for its huge size and huge requirements. Therefore, it is not possible otherwise to achieve such high pressure except by using hydraulic pressure. And the aircraft braking also uses hydraulic pressure, which also requires fairly high degree of power, and the parking brake and the emergency braking. And of course, almost all the secondary flight controls such as speed brakes, the spoilers, and the thrust reversers, almost all movable and all controls are being operated by hydraulic systems. Okay, yeah, we have talked about this very often, the flight controls, but since it's part of the lesson, I will cover it once again. Flight controls as a system, they form a group, and what are the primary flight controls? You are all familiar: aileron, elevator, and the rudder. And other secondary controls are the flaps, the spoilers, the speed brakes, etc., or the secondary flight controls. And there are other small trim tabs and spring tabs and so many other tabs which are well beyond the purview of this lesson. Uh, while we are on the subject, I just want to add some more. In the olden days, and even now in many medium range planes, the flight controls are operated by push-pull cables which are directly connected to the control column of the cockpit, which is operated by the pilot, as I have shown in this picture. They are all directly using jacks, not exactly jacks, rods and cables which operate the flight control surfaces. However, in most modern jet aircraft, as I told you, they require a lot of power to move and be effective. So they all have jacks which are in turn operated by hydraulic power. So there is a small movement with the cable or an electronic signal which is electrical or electronic signal which goes to the jack, which moves the jack, which in turn provides the very highly required hydraulic power to the flight controls. So they are called power operated or power controlled flight controls. Okay, the next important system which we are going to discuss is the avionics system, and its navigation avionics systems. You must understand there's a need for a lot of data processing in terms of processing the navigation information, the performance information within the aircraft and present it to the pilot, which is all achieved by different processors and different computers within the aircraft. So the aircraft incorporates quite a good number of such computers, and which are then integrated and displayed to the to the pilot in the cockpit, so that he can understand and process the information and fly the airplane efficiently. So in fact it aids in automating his all the required data processing job to a very high degree, and which is otherwise it's very difficult for the pilot to uh, fly, to integrate so much of information in one go. So to that extent, these are all very important. At this stage of the lesson, it's enough to leave it at this, because we don't need to go into the elaborate details of the functioning and the other detailed aspects of this system. Let me cover what all this navigation avionics systems integrate. As I told you, it is all integrated system. It contains the aircraft performance database as to how much fuel it's going to consume, what speed it's going to get, if the temperature were to be high, how much it can go, how fast it can fly, if the load were to be high, how much what is the range it can achieve, and one whole lot of information is contained in the aircraft performance database. And of course, the navigation database, which is loaded uh, by the operational managers in approximately once a month, which contains all the navigation information of different waypoints, airports, navigation aids, etc. Then, of course, the flight management guidance and control database is updated frequently. The navigation avionic aids that are contained as a part of this system are the automatic direction finder, which is called the ADF, the VOR, the GPS, the inertial navigation system, and the distance measuring equipment. Then there are other avionic systems such as weather radar, the traffic collision avoiding system, and something called the A cards, where the information and information of the flight is centrally controlled and loaded into the computers, and of course the satellite communication, which are used nowadays in very many commercial planes and frequently used in business jets as well. So these are the popular systems that are incorporated along with as a part of this navigation and avionics systems. Here I have shown the picture of a weather radar and the picture which is presenting to the pilot in the cockpit. As you can see, there are some red patches, yellow patches, and the green patches. These indicate different degree of turbulence in the atmosphere, and the red ones are the ones, red areas are the ones which the pilot will surely avoid. He will never even venture closer, because it is likely to give rise to very high level of turbulence. And of course, yellow is to be avoided as far as possible, and in worst case scenario, he can just about skirt along with yellow. But green is something which the pilot can negotiate. This is what is weather radar. Which I thought I'll just briefly mention is the traffic collision avoidance system. There is a highly sophisticated computer incorporated in the plane, which can communicate with the similar computer which is fitted in all other planes when flying, and it can reach to all the planes flying in the vicinity of its own plane itself. So it is able to communicate fairly fastly, and it's able to understand what each other plane is able to do, and there is a voice instruction that will be given to the pilot in case of any collision threat. That means in case any two planes are approaching closer to each other, there will be an instruction to climb or descent, or increase the rate of climb or increase the rate of descent, so as to so as to avoid any collision. It's important for us to understand that these computers computing power is much higher than any information that a pilot can process, and so the pilot is usually trained to follow the computer instructions verbatim, rather than trying to analyze the situation on his own. The next system which I want to talk about is the autopilot system, which is again very highly sophisticated and highly integrated with several systems, which drives all the control surfaces and directs the different parts of the plane. It's enough to know that the autopilot panel is usually located right on the top of the instrument panel, and so in the common in the center, so that both the pilots can easily reach and make the required changes as required for the phase of the flight. Next is a very interesting and an important system, that the indicating and recording system. In that, I just want to highlight the cockpit voice recorder and the flight data recorder. I don't have to elaborate anything of this because you are all familiar. This flight data recorder it records several parameters of the plane, such as aileron position, the rudder position, engine temperature, what is the speed of the aircraft, and so many data is recorded, and it is stored depending on the flight time of the aeroplane. So, and which is usually located in the tail section, which is a safe section, and these are all highly well sealed, and they are well protected to withstand very high temperatures, very high pressures, and they are able to withstand any water ingestion, even if it is falls in the sea water, and they all carry a inbuilt battery to transmit signal so that it can be located in case of an eventuality. The cockpit voice recorder also is very similar equipment. But normally the entire flight duration cockpit voice may not be recorded. In many planes, in the last 45 minutes or last 4 hours, like that, some duration would be recorded. The next system which I want to talk about is the oxygen system. The need for it is, I'm sure you all well understand the need for it. You all must have traveled in planes, and you all, I'm sure, know that should there be a need due to cabin pressure drop, the oxygen mask will drop automatically from overhead panels and we can use oxygen. In addition, the crew have their separate oxygen systems, and there are handheld oxygen cylinders which are used by the cabin crew should there be any need for the passenger in some critical condition. But here I just want to elaborate that the larger commercial jets which fly over long ranges, etc., they incorporate a system of chemically generating this oxygen. And smaller jets, business jets, etc., they have oxygen stored under pressure. Here I have shown pictures of an oxygen system, aircraft system, and the handheld oxygen cylinder as well. Come to the end of the lesson, and I hope you found the lesson interesting. As usual, please feel free to offer your critical comments and any additional inputs to improve the lesson content uh, in the following email which I have given. I thank you all for listening to this lesson once again.